Okay, so today we're going to be talking about electric fields. So what this is this is going to be creating a version of what we did yesterday with the Coulomb's law fun stuff. So an electric field is the amount and direction of pull per charge in a space. Okay, so here's the deal. That's the definition. If you looked it up online, you'll find something akin to that. So there are a couple rules here. Rule number 1 is it's going to be a space. Let's do a picture. Let's do an example here. I've got a positive charge. This is also stapled to the screen here. All right, this one's not moving. Okay, so I've got a positive charge. I want to know where I would want to go if I were standing right there. And the first rule is you act as if positive. Alright, so you're always going to draw arrows as if you were a positive charge, okay? Every time. You will never, ever draw arrows as if you were a negative, because that's not the convention. Alright, and conventions, just like tradition, is how we keep our balance. So, if you were standing at this dot, which way would you want to go? You'd want to go up. That is the direction you would want to go, because you are going to want to move away from this other positive charge. Okay. So, rule number 2 is when you draw arrows, the arrows should never cross. Ever. Okay? So what we're going to do is we're going to draw this same kind of thought process basically everywhere on this area. Okay? So if I were standing right there, I'd want to go this way. If I were standing right here, I'd want to go down. If I were standing here, I'd want to go this way. Okay? Ta-da! So far, so good. Now, you can do it diagonal as well. These arrows will never, ever cross. The reason why they're never going to cross is because that would mean you'd be pushed 2 different directions in the same spot, and that does not make sense at all, physically speaking. So it's going to look like a sun, right? It's radiating outwards. Okay? So the third rule is that the closeness of arrows determines strength. Alright, so here's what we mean by this. If we extended these down to here, do you see how these are very close to each other compared to over here when it's much further apart? Since they're closer to each other, that means they're stronger. So you're going to have a stronger push in this area, which makes sense because you're closer to the charge than you will in this area, because that's a much more spread out for the arrows. Now, how many arrows do you have to draw? You have to draw enough arrows to where it's obvious you know what you're doing and where you can get a picture. I would shoot for at least 4 arrows from each charge, but if you don't know what you're doing, you should just keep drawing arrows, the same thing that we did here. Okay? So that's that. Ta-da! We're going to draw one with 2 charges now, 2 charges that are opposite. So we're going to put a plus here, and we're going to put a minus right there. These are 2 charges. The charges are going to be stuck where they are. I'll draw a little pin in them again. and we are going to draw the electric field. Now remember, rule number 1 says that you are a positive charge. So if I were standing right there, which way would I want to go? I would want to go to the right. We'd want to go to the right because we hate positive charge and we want negative charge. And I'm just going to draw that arrow right there. Let's draw all the horizontal areas. Now if I were standing right here, which way would I want to go? I would want to go to the left because I am going to be repelled by the positive. Now some people might be thinking, but wait, you're attracted to the negative here and you're repelled by the positive. Why is the repelling going to win? The repelling is going to win because the repelling is closer to you in that area than the attracting is. Because remember, the further away you are, the weaker it gets. And it's going to be the same thing over here, but the opposite. So it's going to go to the left, like that. Because you are more attracted to negative on that side than you are repelled by the positive. Okay, well that's easy, Mr. Keeney. But what about all the other areas? Okay, well let's think about this spot right there. It's right above the middle, okay? Which way are you going to want to go? Well, you are getting pushed by the positive in that way, give or take. You're getting pulled by the negative that way. Now do you see how it makes like an X and this one pushes up and this one pushes down? This up and down are going to take each other out, but both of them are pushing to the right. So this is going to be a flat arrow going to the right. And it's going to be the same thing right there. And it's also going to be the same thing right there. So as long as you're in the middle, you are going straight to the right. Now, if you picked someplace closer to here, that means you're going to be more repelled by the positive, so it's going to be going like that. And if you pick somewhere over here, you're going to be more attracted. It's going to be somewhere like that. What we're going to do is we're going to connect these arrows all together to see what kind of path it would make. It would make something that looks like this, like a rainbow. I guess an upside-down rainbow. And it's going to be nice and symmetrical up here too. So how far does it go up? Well, technically it goes up forever. Okay, so I can draw this one that goes like this, goes up, 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 and then it comes back down, down, down like that. Now, do you have to draw ones that are huge like that? No, because you can get the idea. Eventually, after you get this one here, it's going to flatten out, and then it's going to do the same thing over here. Alright, you get the idea. So now let's do some like charges. We'll have two positive charges together. Okay, so let's do the easy spots here. Let's see if you can figure out the charge on these three spots. Okay, hopefully you did that now. This one is going to be going this way. This one is going to be going that way, and the middle one is going to have a force of 0, so I'm not going to draw an arrow there. But in this area, these spots do have charges, or do have forces, sorry. Ta-da! So it's going to look like that. Now, if I pick my areas again, same kind of thought process. This one is going to push this way, this one is going to push this way. The left and right is going to cancel out this time, and it's just going to go up. So what's going to happen is these are going to go up. This is going to go up. And then this is going to go down. So it's going to be an asymptote, if that word means anything to you. But Mr. Keeney, what about the space in the middle? Well, technically all of these do that. You can get as close as you want to the middle. Oh, you shouldn't draw them crossing like that, but I can't erase. So it's going to, they're going to fit in closer and closer. It's just how many do you want to draw. And then these are all just going to arch out until you get to your flat line here again. Does that make sense? And you can follow this all the way around. It's going to be the same on this side. So it's going to go that way, 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 and it's going to go that way. Alright? So that's what your field is going to look like for two like charges. Now anything that's a combination will just merge the two pictures together in one way. Kind of like this. Oh, sorry, we're doing a stronger charge first. So let's say we have a positive charge and we have a -2 charge. Okay, so the -2 charge is twice the man that the positive charge is. So what are we going to do? What does that mean? Well, let's start off with the original 3 spots. Can you figure out those 3? Pause the video. Good, I hope you did it. So this one is going to go this way, this one is going to go this way, and this one is going to go this way. Now, when we're up here, this is going to be pulled more towards the negative charge, so it's going to be pointed downward slightly. It's not going to be horizontal anymore. But there will be a spot where it is horizontal, and it's just going to be closer to the positive charge this time. And what's going to happen is it's going to follow that pattern. It's going to be a same picture, just skewed to the side. Alright, so hopefully you can see the similarities here. The double positive charge would work the same kind of way. Alright, let's do one more thing. And that's for multiple charges. So let's say we have a positive here, and we've got a negative there, and a negative there. Now don't get buried with all this hard stuff here. It's the same stuff you've always ever done. So the first point that I would pick is right there. Anything that's symmetrical is a good starting spot. So where are you going if you're in that spot? You're going to be going this way because you hate the positive and the negatives cancel out. One's pulling you up, one's pulling you down, and so they take each other out, and it doesn't matter. So this charge right here is this arrow is going to go right there. And this arrow is going to do the same thing. So we've got a line of symmetry right there. Now, if you were over here, which way would you want to go? You'd want to go away from the positive, towards the negative, but you'd be pulled up that way towards that negative. Not a lot, but it would look something like that if you put them all together. So what is it going to look like? It's going to look something like this, something like that. If I drew one in the middle, it would do something like that. You know, and you can just follow the picture around. It would look like that. Well, that one's a bad picture. I should erase that one, but I don't think I can. So this one would look like that. Well, I suppose it looks alright. Alright, what about up here? What about in this area? Well, the positive charge is weaker. You're pointed to this way and you're pointed to that way from the other negative charge. So it's going to do something like, so this one's going to come up, this one's going to come up. So there is going to be a point where these guys and this one take each other out, and it's going to bend. Let's see here. Where the attraction force is going to cancel out. So there's going to be, maybe, I don't know, right past the point we measured, where this one will start going this way, and this one will start going that way, more or less. Alright, so that's what will happen up there. Hopefully you get the idea, but you just do it point by point, and you don't make a big deal out of it. We're going to do some practice with this tomorrow with a fun lab.